Welcome and hello. This is a video lesson in HY-8, and in this lesson we're going to be discussing Culvert data, specifically shapes, sizes, materials, and types. All right, so if you're following along, I will be referencing the user's manual and the HDS5 document in this lesson. To get those documents, you can go up to the Help menu. The user's manual is this first option, H8 Help, and then the HDS5 document is this third one, HDS5 Documentation. That'll open up as a PDF, and I will, again, reference those during this lesson. Let's go ahead and get started. This content involves Chapter 4 of the User's Manual. It starts on page 43. I'm going to start by creating a culvert crossing. And then what we talked about in Lesson 3 was the crossing properties data over here in the left half of this dialog box. In this lesson, we're going to talk about the right half of this dialog box, not all of it, but parts of it, such as names, shape, material, Manning's N, and culvert type. The rest will be covered in later lessons. Just as a quick preliminary info, right now it starts us off with our crossing we just created and one culvert called Culvert 1. We can go ahead and rename that Culvert 1 over here in the Project Explorer, which is, oops, I think I deleted it, Add Culvert, click OK, just accept that we have some errors. Now, if this Culvert 1, we can rename it right here. I can call it, say, Culvert A, for instance. Now it's called Culvert A, and then we can open up the data. It says Culvert A right here. One important distinction to make is with each culvert crossing, we could have multiple culverts. So I could add a culvert, and then that's Culvert 2, but I could rename it to Culvert B if I want. And then for each culvert, whether it's A or 2 or B or whatever, it can have multiple barrels. So I may have misled someone watching lesson 2, but basically you don't need to have a separate culvert defined up here for each barrel. There's actually a field down here for number of barrels, which the default value is 1, but of course that can be a larger integer if you want. What you may need to do is define different culverts up here in this list box if any of the properties associated with those barrels change. So for instance, I'm going to bring up this image here. This is from the HDS5 document, page 151. Here we have what looks like 6 identical barrels. So this could all be the same culvert in HY-8, which would be, for instance, culvert A. We wouldn't need a culvert 2, so we can delete that. And we would just put number of barrels, 6, like that. However, in another example, if I scroll down here, we've got some box culverts right here. Now, in this situation, we would need 2 different culverts defined. Why? Because, well, we have 2 different shapes and 2 different inverts. This center one here has a lower invert and a different shape than the left and right side. And then on the right here, we would also need 2 different culverts. The first one defined with the lower invert, and then the second one would have 2 barrels with the higher invert, even though they look to be the same shape. Speaking of shape, now we can define some of our culvert data associated with this culvert A. So we have the name, we can rename it right here, which we've already done once, so we'll leave it like that. Then we have the shape. Our options for shape are circular, concrete box, elliptical, pipe arch, and there's about 10 total, so you can read them if you want. The most popular ones are circular and concrete box. So based on the selection here for the shape, that will dictate a number of other parameters further down, such as the material and the dimensions. For circular, the only dimension you need to type in is the diameter. So if you had a 6-foot diameter culvert, you just put a 6 here. If you had a shape that was concrete box, then you'd have to define the span and the rise. So the span refers to the width. That could be maybe a 4-foot by 4-foot. The rise would be the vertical elevation for a total flow of 16 square feet in this case. There are a few other shapes. So for instance, you don't always define the actual numbers here, but you pick from a list. On pipe arch, for instance, the default is 17 inches by 13 inches for span and rise, and we have to pick those shapes from a table. If you're curious what some of these other shapes look like, then the user's manual right here on page 44 shows the circular, box, elliptical, pipe arch, and metal box. That list is not complete though. The HDS5 document on page 43 shows these 4, which we've already seen. And then on the next page, it shows these ones here. We have the arch, concrete box, metal box, and then we have 3 different arches, normal, low profile, and high profile. So these are all called open bottom culvert shapes. All right, so that should cover what we're talking about here. Anyway, back to the size. If we have pipe arch selected, we click define, and now we get to select one of looks like 12 different size options. Where this list here has an increasing size number, the span is increasing and the rise is also increasing. You may also be interested in the area in square feet. So say for instance, we're interested in number 8, go ahead and select 8. That means 57 and 38 inches for span and rise will be inserted into the form right here, 57 and 38. Let's go ahead and check one other shape. How about elliptical? And just as before, we have predefined sizes. So if I click on define, now we have a lot more choices here. It looks like it goes down to 40 different sizes for elliptical shaped culverts. Number 8 happens to be 276 inches span by 169 rise. So you can pick that one or you can pick a different one. Whatever you select, go ahead and click OK, and then those units get updated for span and rise. Also, another parameter is the material. So we have steel or aluminum or concrete. Those are the only choices available for elliptical. But if we select circular, now we have more material options, concrete, steel, aluminum, and then a few different plastic options. Based on the selection you make here for material, that will update the Manning's end value, the roughness value. You can just type in whatever Manning's roughness value you want right here, so I could update it to something different. But just so you know, whenever you select the material, it will update that Manning's end. So let me go ahead and change it to, how about PVC? And that changed it to 0.011 for the Manning's roughness coefficient. All right, the last culvert data parameter we're going to talk about in this video is the culvert type. We have a few different types here: straight, broken back, and single broken back. I need to change the shape to, let's go with concrete box here. Concrete box. Okay, we should have some more options. There we go. Side taper and slope tapered are also an option. You know, I thought when I selected circular, it gave me something else. Okay, so with circular, I also have two different types of side taper. There's circular and rectangular. All right, so the straight culvert type is the simplest. It's just a straight culvert. There's nothing fancy about it. There's no tapered involved. There's no change in slope involved. It's basically your standard culvert type. So start with that unless you have reason to add something different for your culvert type. All right, so the other types are side tapered. A side taper inlet provides a more efficient inlet controlled section to increase the culvert performance. So once we select side tapered, we have a few more parameters to provide. That's the face width, the side taper, and the face height. The face width right here, this refers to the width of the enlarged face section. So if our diameter, for instance, is 4 feet, our face width may be something like 6 feet. The user manual shows what I'm talking about here. Here is the side taper diagram. I'm on page 49 now. This width right here would be the side tapered width. So it has a wider approach before it actually enters into the culvert. So this distance right here would be our 4 feet diameter. And then this distance here would be our 6 foot face width value. And that value goes right here. The user manual also mentions that the face width should not influence the headwater calculation. So if increasing or decreasing the face width is affecting the headwater, you should increase the face width until the headwater water surface elevation no longer decreases. All right, so the next parameter here is side taper. We need to insert a number here between 4 and 6. So this refers to the side taper ratio. Let me make this a little bit wider, expand the units. So it's basically a ratio to 1. So 4 to 1. I typed in a 4 here. This is the flare of wall of rectangular transition, or units of wall length per units of flare, or circular in this case. You can select either circular or rectangular. We have the same field when we get to the rectangular shape up for a concrete box. Finally, the face height is the parameter right here. This is going to be between 1 and 1.1 times the diameter for a 4-foot diameter circular pipe. Let's go ahead and type in 4.4, so that's the maximum. And the user's manual has an image of that, this H sub F right here. This is now the profile view or elevation view, it's called. Here's our 4 foot diameter, and then this would be our 4 to 4.4 face height right here. Yeah, between 1 and 1.1 times the barrel height. All right, so let's switch on shapes now. That was circular. So if I click on concrete box, and then for the culvert type, we stick with the side-tapered. We basically have the same data. We have the face width and we have the side taper, but we don't have the face height. The next culvert type is slope-tapered. So let's go ahead and make that selection. A slope-tapered inlet increases the culvert performance by providing a depression and a smoother transition to where the constant size culvert begins. All right, so we've seen some of these parameters already before, the face width, the side taper, but now we have 4 new ones. That's the depression slope, the throat depression, whether or not the culvert has a mitered face, and then crest length, which will appear if we say yes to this. So if we say that it does have a mitered face, the mitered crest length needs to be entered here. That's the length of the upstream paved crest at the stream bed. All right, but as for the depression slope and throat depression slope is somewhere between 2-to-1 ratio and 3-to-1 ratio. So again, we have the ratio that it's asking for. Let's go ahead and just give it a number 2 for 2-to-1 ratio. This is the slope between the entrance and the throat of the invert. So let's break out the user's manual. Down a page, we have the slope tapered diagram here. This is the slope that it's referring to. So this would either be a 2-to-1 ratio or a 3-to-1 ratio, horizontal to vertical. And then the other parameter, while we're looking at this figure, is the throat depression. That is in feet. It's the vertical distance between the stream bed and the throat invert. So here's the stream bed invert. Here's the throat invert. It's this vertical distance right here. So we could go ahead and give that a value as well, maybe 4 feet. All right, the last 2 culvert types I'm going to discuss together. So we had slope tapered already, straight side taper. Now we have single broken back and double broken back. This is where there are 1 or 2 slope changes in the culvert. I'm going to show the user's manual on page 50 now. This is figure 4.4. Here we go. So this would be a single broken back and a double broken back. You see, basically we have 2 different sections or 3 different sections of culvert that make up the entire culvert. And then there's 1 or 2 changes of slope within the culvert itself, respectively, for single and double. The purpose of shaping a culvert like this is to save on excavation costs and also to force hydraulic jumps, which will cause energy dissipation and reduce or eliminate the scour at the downstream end of the culvert. So definitely some good purposes for doing something like this. HY-8 computes each section as a single culvert and uses the result from one section as a boundary condition to the other section. Now, which section does it calculate first is determined in a table on the following page. The top table 4.1 is for single broken back culvert crossing, and then further down we have table 4.2, which is for double broken back culvert crossings. So let's look at the single broken back culvert crossing first. Basically, the order is upper, and actually, before we do that, I also need to point out that the names for these different sections is upper and run out for the single broken back. For double broken back, the 3 sections are called upper, steep, and run out. And these are abbreviated with UR and US and R. So if we go back down to that table of the order of calculations, if the upper and the lower section are steep and steep, then the order is UR, meaning it first calculates the upper and then the run out after that. But if it's steep and then mild, same thing, run out and then upper if it's mild steep or mild mild. Now, whether or not a section is mild or steep is just basically if the critical depth is greater than the normal depth, that would be steep. And if the critical depth is less than the normal depth, that would be mild. Okay. That same concept is used in the double broken back culvert crossing, which is what you see here. The only difference is instead of 4 different options, now we have 8 different possibilities for mild or steep for the 3 different sections of the double broken back culvert. 2 to the third is 8. And then here is the order. Remember, U is for upper, S is for steep, and R is for run out. When viewing results for the broken back culvert types, you need to select a specific section to view the results for. So that's coming up in a later lesson. But anyway, that's all I had for this lesson. What we talked about was culvert data, specifically the culvert name, shape, material, size, and type in HY-8.